Tutorial 4, question 5. The population of Bangladesh was estimated to be 105 million in 1995. In 2010, it was 148 million. If the population continues growing at a constant relative growth rate and there is 144,000 kilometers squared of land in the country, in what year will there be 10 meters squared of land per person? Okay, so first we start with the relative, for the general equation for population growth, which is dp over dt is equal to kp. Then we solve for this differential equation. So in doing so, we would take dp over dt is equal to kp. We take p across, 1 over p times dp over dt is equal to k. Then we go again and take dt across, and we get 1 over p dp is equal to k dt. Then we obviously have to take the integral of either side. So the integral of 1 over p dp is just ln p, and the integral of k dt is just kt plus c, because that's a constant, so we just add t. Then we are given two values for t, and that is t in 1995 and t in 2010. Now we can set 1995 to be t0, it'll be easier to work with, and we can set t2 to be 2010 to equal to 15, because 15 years after 1995 was 2010. Then the values for the population in these specific times. In t0, which is to 1995, the population was 105 million, and for the population in t2, which is 15, was 148 million. Now using those values, we'd have to solve for our c value. So using the first value, which will be easier because I will have t of 0, we'll say ln of 105 million, because that is our population there, is equal to k times 0 plus c. Therefore c is always equal to ln of 105 million. Now we need to solve for our k value. So we'll use the other two values for t and p. Now we have ln p is equal to kt plus ln of 105 million. This was our previous c value, which we now figured out. Then now we use our second value for population, which is ln of 148 million is equal to 15 times k, because we have t2 equal to 15, plus ln of 105 million. And then obviously we solve for k. We take ln across, and we get ln of 148 million minus ln of 105 million. Using our ln laws, that is just equal to ln of 148 million divided by 105 million, and all of that divided by 15, which will give us our k value. Okay, and then now we can put our k value back into our original equation, and we'll get left with a simplified equation of ln p is equal to 0.023, which is our k value, t plus 18.47. Now 18.47 was the simplified ln 105 million, which is equal to 18.47, which was our c value. And then now we solve for t. So we get this whole thing with respect to t. T is equal to ln p minus 18.47 all over 0.023. Now we need to get the population at that point that we want to work out how many years it will take. So the population of that point, we are told that the total amount of land is 144,000 kilometers squared, but they want to know in what year will there be 10 meters squared of land per person. So we obviously take the 144,000 kilometers squared, convert that into meters, so we'll times by 1,000 squared, and divide by 10, because it's per person, will be 10 meters squared per person, which we are given 1.44 times 10 to the 10. Then we sub that value back into our p, right, for ln p, and we get ln of 1,44 times 10 to the 10 minus 18.47 all over 0.023, which gives us 213.9 years, which is the answer.